to turn on the clicker. Yes. Okay, I'm going to talk about Flowtype and the wonders of statically typed JavaScript. And for those people who follow me, maybe on Twitter or something, they already know, but I will tell you some facts about me. So, I'm a huge Flowtype enthusiast. I've been using Flowtype since version 0.15, and this was quite a while ago, like 1 year. This is 10 years in web technology time, I guess. And as a comparison, today we have version 0.38. So they iterated on it a lot. I'm a digital nomad, and I'm mostly working as a system engineer for Amazy.io. So it's a Swiss company. We are building DevOps tools, optimizations, and yeah, we are basically deploying Drupal instances. But this sounds a little bit fun. What has this to do with React? The fun part is we are using Drupal as a backend, and because Drupal is a very good backend, and we decouple it and use React as a front end. So I'm also very used to use React and React Native. So that's about that. And I don't want to talk about Flowtype like in detail. So if you have some experience in Flowtype, this is good. If you don't have any experience, this is no problem at all. I'm talking a little bit about the general concept of it. And if you want to go into Flowtype, if you don't know where to start, I've been working in my previous company, which was RUNTIME. So if you know that, they are producing running and fitness apps and bodyweight training apps, and they have been leveraging React Native a lot. And I tried to introduce Flowtype into the team. I was convinced that this technology is really, really nice to work with, and that it will help us write more stable code. And to onboard the team, I was writing this guide. It's called Flow Guide. You can find it on GitHub. I will put up the slides so you can see the link if you're interested in that. Another project I've been involved in was the Flowtype project. So if you have been using Flowtype already, you probably know this. This is the official repository maintained by Facebook, and what it does is it provides you with library definitions for third-party libraries like Lodash or REDUX Saga or stuff like this, and provides you with the types you need for type checking your dependencies. So you can imagine that I love types a lot. So it's kind of great to have types in your JavaScript. And I made it my personal mission. That's why I'm currently on the road with the Reactive conference, the Reactive Roadshow. My mission is to make JavaScript a nicer place. I wanted to make it a trademark, so okay, and we know there are different tools to do the job. There are different tools to make things a nicer place, to make JavaScript a nicer place. Like TypeScript, or the newest cool language out there, ReasonML, which is maintained by Jordan Walks, like the creator of React. So, kind of cool. But I'm going to specifically, like my examples will target Flowtype, of course. Okay, and you should know, like as a preset to set the stage, not all types are created equally. So we have runtime types. And runtime types are kind of cool. These are like the types we use already, like during runtime in our JavaScript environment. So if you have a browser, I just take some engine there, which you probably know. It's the V8 engine from the Google Chrome browser. And you probably noticed this looks like a mousetrap, right? So I think a runtime type system is kind of cool because you can run your code whenever you want without anyone complaining. But it can bite you, it can hit you very hard if you are not very cautious. And on top of this mousetrap, we have this very nice slag of cheese, you know? And I think this is kind of funny because I work for a Swiss company right now, so yeah, we like cheese a lot. And JavaScript is like this small, nice piece of cheese we want to get. So what we try, we are not stupid, we know a mousetrap can be tricked, right? We can try to sneak in with one hand and try to remove it without the mousetrap activating. But we have to watch out. If you're too fast or if we do something wrong, if you're not careful, it will snap our fingers, and you know programmers need their fingers. It's kind of bad if you don't have fingers. So that's that. So very dangerous. On the other hand, if I think about JavaScript, I imagine a nice game of Jenga. So you know this game, it's very fun. It's very fun to play Jenga. You have this tower of wooden sticks. And what you do is you pull out the sticks and you put it on top. And it's a very good analogy, because your JavaScript program, when you initially build it, is very concise, it's very clean, right? It's like a nice house you built. And the longer the project takes, features will be added or requirements change. You just pull out some code and you put it on top and then you strip it away. And you know, the code gets brittler and brittler, and you have no idea when this whole thing is going to blow up. So, yeah, like two hands are always busy. One is like playing the Jenga game, one is playing the cheese game, and like with the foot you try to defuse the bomb. So this is not good. I think this is very hard to handle. It's a lot of mental effort you have to keep and carry around while you try to build your application. Now let's talk about static types. And static types are kind of like frozen, like in a stasis. And it's also very nice. I mean, it's like, you cannot see that, but it's like flowing, like the water is flowing. It's a nice reference, so I get all the puppets out here. And I think static types are really cool. deal with that, I guess. Why they are cool is because of that. What we usually have, if you think about an application, we have a function somewhere which we want to use. And the function expects a type, like T1. And this is the input. And the output is T2. We call this a pure function. We know if this input goes in, it should output this value. Unless you have side effects in there like random time or maybe like a fetch or something. So we just assume this is a pure function like a REDUX reducer. And the static type system is really, really good in telling you if you're using a function wrongly. Because if I say T1 is a string, the type system can tell me right away, if I put in a number, hey, this is wrong, you should put in a string. This is very nice, and static types accelerate in telling you more about your code. If you leverage this concept, so we have one function, we put them together into a module, like a node module, a library, or an application. You can think of it as your utils folder where you put all your utility functions for your application. We just have a set of functions which is designed with a certain input and a certain output. And if we combine these functions, the output of function 1 can go as an input to function 2, and since this is like under our control and the static type system can analyze the flow of your code, it can tell you right away if you're connecting the functions incorrectly. The same goes for third-party libraries. We can tell the type system how a third-party library is designed. We can tell what kind of functions it exports and how these functions look like. And if all these things are under our control, like as we use the functions in our editor, the static type system can help us write correct programs. To get a little bit more technical, what does a type checker do? What happens on the file system? So what we have is, we have JavaScript code somewhere. And the flow service is going to be a process in the background. It just starts a daemon, it indexes all your files of your project and parses it. And how it parses it as an abstract syntax tree. And an abstract syntax tree is nothing else than a data structure. It is a very concise set of data. So you can say a program has a function called, this function has a parameter 1 and parameter 2 with a type string and a type number, and has the return type string. And with this data structure, it will launch an algorithm which analyzes your code, it analyzes the flow of the code, and will output the result either as an OK or as an error. If there's an error, it will return you a data structure as an error, or how you configure it. Sometimes if you use it on the command line, it will just put out some lines of code so you can read it like as a human being, or you can output it as a JSON. So a lot of people think, well, if I have a type system, this reminds me of something. Sounds very familiar, right? So, and what we don't want, or at least what I didn't want, I was a Java developer myself. So the worst thing I had, like the worst experience in Java was, I could not run my code if I don't satisfy the compiler. Because the compiler cannot make the binary to run the whole thing. In JavaScript it's the other way around. You just throw code at it, you can do whatever you want, you can even just strip away the prototype of the object, like the global object, and nobody cares. The runtime is just doing it. And what I want to tell you is that with a type checker like Flow, you don't have to give up this dynamic attributes of JavaScript. So let's see. We have an ecosystem, right? So if you're, I don't know, how many React developers are here? Just raise your hands. All right, so many, okay. So if you're a React developer, you probably know certain tools what we use to transpile our code. For instance, we have Babel. So I just want to point out how these tools work together. We have Babel, and Babel has probably also an AST parser. This is a different one to Flow's parser. This is very important. So what it does is you install a plugin which lets Babel recognize the Flow syntax, because Flow is just a small addition to the ECMAScript standard syntax. So you can see you have your program and there is some code in there, and then it finds some Flow annotations. And the Babel plugin strips it away completely. So the runtime doesn't even know there is a type system used. And we get plain JavaScript out. So this is the normal output how you would expect it, either with Flow or without Flow. In parallel, we have our Flow process, which does, as I told you, its own ASD parsing. It can understand pretty much everything Babel does. It also does understand decorators like ES7 proposals, decorators, class properties, and all this stuff you probably need for React applications. And it will accept the Flow statements, and it will use it for analyzing inferring types. And the inferring part is very important, because I talked about Java. In Java, you have to define types for every variable you use. This is very tedious sometimes. And in Flow, you don't have to do that. Flow is very clever in making assumptions of what types you're using. The only thing you have to really type are your public interfaces. And this is usually what is a best practice. If you're exposing an interface, you should type it. And in the end, we will get data out. So there is no JavaScript involved. There is no running of JavaScript. Flow does just analyze it. So just a short question. Just raise your hand. Who is afraid of JSON data? See? Yeah, JSON like an object, right? Nobody is afraid of JSON data, so you're not afraid of a type checker, theoretically. I was really afraid of it, because I thought it would introduce a lot of breaking stuff. So what we get, we have this parallel system. So just imagine we just have our JavaScript, but with the types we get three advantages. We have automatic documentation, we have a way to analyze our code, and we get a lot of maintainability. Let's start. I will just show you some examples to explain what I mean. So first we get into documentation. And what we usually have, let's start from the beginning. Let's assume there is no type system. So we start with plain JavaScript, and now it's getting more interesting because we see code to explain. So we have a function getUser somewhere. So probably you have built this yourself already, and you expect an ID. So my question to you, without looking at the implementation, what is ID?
Number.
A number. Well, could be. Could also be a string, right? I always had this discussion with myself, and I was like, yeah, this is most likely a number, because in this system we use a number always. and then suddenly it's a string because the backend changed the specs to UUID or something, right? So this is very hard to tell without looking at the implementation. Also, is this asynchronous or is it synchronous? So most people would reason, yeah, get user sounds like I'm retrieving data from a server, so it's asynchronous. Node.js has this very funny way of defining sync and async by adding this sync syllable in their function. So if you read a file, it has a read file and a read file sync. So this is a hint. But wouldn't it be much nicer if we could define a return type and we can see on the return type if it's async? So this is not possible with plain JavaScript. So what we do is we try to add band-aids. We try to patch it. So my first attempt of doing so, and I've done this for many years, I tried to make this work. I wanted to make it nice so other developers can use it. And I tried JSDOC headers. And JSDOC headers make a lot of sense because a lot of people come from a Java background or a C# background. They know the syntax, kind of. It's very familiar. And it's also, it looks nice. It's just, yeah. You can really get all the information in there. So we have a parameter string, ID, with a comment there, and we have the return type promise, which is resolving a user object, and another comment. So what's the problem with this? First of all, my biggest problem with it is this is not standardized. I have not yet found a proper way to express all my stuff. Sometimes I just wanted to express a module, sometimes I wanted to express a class, sometimes I just wanted to refer the entities in between it. It's so hard to memorize the syntax. And there's no tool, at least I don't know it, if you know one, please come to me. I don't know a tool which tells me if I'm doing something wrong here. Maybe there are some linting rules or something, but I'm not sure. And also we need to keep these values in sync. So if I add another parameter or switch a value, I need to make sure to update the docs as well. The only way to automatically check this, there is no automatic check of this, the only way to check this is code reviews. And we know we are all busy, we have a lot of things to do, someone made some small change, not really important, and he's like, yeah, just merge it. And then suddenly, then he's like, oh, okay, he changed this to a number or whatever. And this is not reflecting. So now you have two implementations. You have the implementation and you have the documentation out of sync. And I tell you, wrong documentation is even worse than no documentation at all. It's really the worst case. Because if you're doing something, you're like, oh, well, I'm calling it with a string, why is it breaking? Nobody will tell you. Maybe the runtime telling you that string is not a function or something, or whatever, type is not a function, something like this. So this is hard. And what we also do, so I also like the generation of JSDOC is not very nice. So what I usually do is, in a GitHub project, I would put a README file there. Don't get me wrong, please write README files, they're super important. They give you a good insight of the API. But I don't think that's really necessary to make this kind of stuff that you have to, if you use an API to go on a website, check it out, then you make a typo, then you go back and you're like, ah, this is a nested object, so I need to put it one, like, you know what I mean, like if you use Webpack or something. There's a lot of configuration going on, a lot of typos, a lot of errors potential. Why can't we have this? Like autocomplete. That would be great. Why? Like, if you use chest, I have this problem, there's this expect function, and I want to check a value, like my test, and there is something like a to-be function, I think. Yeah, there's a to-be function with a specific interface, and this is the Flowtype interface here, to equal, which gets a value any and returns void. So now we can easily do this. Why is it so hard to? I mean, there are other tools like Turn.js, which can make assumptions about your code. I don't say Turn.js is bad, but it doesn't, it makes some assumptions on the code which is semantically maybe not correct. And Flow does this much, much better. So let's see, how would we achieve that? How does the syntax look like? So we have JavaScript, or we have a beach ball of death. Yeah. So we have JavaScript and the Flow annotations. We have the getUser function as before, but now we have this green new thing. This is like the new addition to our ECMAScript. We say ID is a string, and it returns a promise which resolves a string. So this is cool. First of all, string and promise are predefined values, predefined types of Flowtype. So we cannot invent our own types there unintentionally. The second thing, if I would use this function and chain it with .10, you know, the promise interface, you would usually have a resolve callback with a value, and Flow does exactly know the resolve value is a string, and now you can have autocomplete for map and all this stuff, or I don't know what function the string interface offers you. So you know this is a string, and if you return this string in the then interface, in the then callback, you can chain it again, and it will infer the type. If you return a number in this then function, it will know in the next chained then that this is a number. It really does very intelligent code inference. If we try to use getUser with 1, our editor, if we configure it correctly, will tell us, hey, you're trying to use that wrongly. And that's super important because we don't have to run the code before we even know, oh, I made a typo there, or I made a mistake there. So we get a lot of code awareness and maintainability out of it. And let's see another example. So I will show you something else where Flow does really shine. We have a file, source some file.js, which exports my class. And it has an array of users, which is an array of numbers. So first of all, we can say, okay, users has to be some kind of, you know, IDs or something which are being handled in this class. So what if the requirements change, and now we say users should be the resolved user objects? Which other code will break? You have no idea. The only way you will notice is either you run it or you have tests, which is also running the code. But who of you has like 100% test coverage? It's like this fairy tale kind of world where project managers give you refactoring time whenever you want. And yeah, no, this is not going to happen. I don't think that 100% test coverage is a good idea as well. We want to be productive. Or what? This is also one thing I really hate. I was super afraid of naming files because I knew if I named a file, it would be here to stay. It's so hard if you move a file somewhere else or if you rename it to find out where I import it all the time. I know there is a ESLint option, but let's go deeper. I export my class. What if I remove this export or make it my default export? Nobody will tell me that something breaks because I make a named import of my class in some other file. Flow does exactly that. First of all, Flow will recognize if you're trying to import a file which is not known. And second of all, it will tell you if you try to import an entity which is not exported by this certain file. Yeah, so this is that. Let's go to another example. For instance, I have a library which offers you a configure method and returns you some configured object. First of all, we have no idea what config means. We don't know. And sometimes you see this kind of very defensive library maintainers, which is also a good thing if it makes sense. Sometimes they just like write this code here. They ask if config is an object, and if not, it will tell you that, or if the URLs in there is an array, and will also notice you if you use it wrongly. But I think this kind of unnecessary defensive programming is a problem. Because first of all, it has a runtime impact if you have to do it many times. And second of all, I don't know, you just spend so much time on GitHub issues because people are like, yeah, I tried to pass this and it didn't work. Why cannot we just tell proactively that you are just using the API wrong? And again, static types are really good. This is a bad example, so let's see how we can do this with static types. First of all, we define our configuration, which is a type, It's object type with a URLs property. And URLs is an array of string. And this is also nice. We can define a question mark here in front of the column. That would mean this could also be undefined, so we are not required to import, to put it into the config. We can also put a question mark over there, then it's a maybe type, then it can be null or an array of strings, so we can really concretely say how the object should look like. And inside the configure we can now safely use URLs, because we know the static type system tells us if you try to pass in an object which is not valid. So this is really good. And another really interesting example, and I will ask you just again to raise your hands. How many of you have been using this command? Oh, actually a lot. You're really brave. I don't know. If I do an npm update on a Redux or a React application, I'm 90% certain that something will break at some point. Maybe you don't notice now, but you will notice in some time. And like in the worst case, like sometime when it's really hard to debug. And like in my ideal world, just imagine we have all these third-party libraries, and all of them are using type systems in certain way. So the type system will force the maintainers to write the code a little bit more modular. And if the code is more modular, and if there's not too much meta programming happening or dynamic programming happening, just thinking about very complicated APIs like Moment.js, and if that happens, we could write library definitions for that. We could offer you a way of defining library definitions for major versions of your library. And if we npm update, we can pull up our library definitions on the next major version and can check if somewhere in the code we are misusing the newest API. So what we can get is something like an Elm experience. If you know Elm Lang, Elm Lang is enforcing you to comply to the semver. If you're trying to change the code in a way which it would introduce a major release change, you cannot publish it until you raise up your major release version. So this is not happening in the JavaScript ecosystem. So maybe this would be a possibility to at least make us aware if there is a breaking change, if you pull up our dependencies. We should get more confidence in our code. I think it's a very important message here. And a lot of people ask me where to start. Like, I have an application, where to start? Yeah, cool, type systems, whatever. Yeah, it is like that. I was also saying that. I have deadlines to meet, so I have places to be. And the easy way is always simple, of course. We start from scratch. We are working on a greenfield project. We can do whatever we want. We can choose whatever framework we want. We have no third-party modules in the beginning. Super nice, super easy. Yeah, this is not the world we are living, right? So we have the hard version. We have an already existing code base. We are already depending on complex third-party modules. Maybe we still have like jQuery in there with some plugins, and it's very tangled maybe, and very, very hard to introduce a static type system, because the first thing we will notice is we run flow check and we get so many error messages that everything is breaking and not typing at all. And I will explain how you could, like an idea of how to introduce it in a complex code base like Redux. Because Redux is probably very familiar, there's a lot of React developers here. So let's see. We try to add flow to Redux. And this is my recommendation. It's not like official way of doing it, but I think it goes really well. We have do's and don'ts. First of all, whatever you do, never type the containers in the beginning. You will just have a very bad experience, a very bad time here. And also, just ignore the third-party stuff. I mean, literally, there is a flow configuration and there is an ignore section. You just put in all the third-party dependencies which are making the most noise. Just ignore them, they are not important. You know why? Because you have business logic, which is much, much more important. So we are coming to the do's. And as I told you, the business logic, we have reducers, we have components, and we have actions. And as I told you before, static type systems are really good with pure functions. And what do we have? Reducers, pure function. Components, if you're using stateless functional components, they are pure. If you're using action creators, if you're not using funcs, they are pure as well. So this is great. So let's start with that. Let's start with the actions. And we have source actions user, so I'm just making up an example for querying a user or something. Bam. So we have this. We have fetch user, const, and fetch user success. And I recognize this is a pattern, but I don't understand why. Or at least, I understand now if, like, since I'm using a type system, I'm not understanding why we're doing this. Because the only way, or the only reason why we're doing this is we are afraid of typos. We don't want to, like if we're using a switch in our reducer, we don't want to switch around. If I'm switching just these two letters, I'm afraid that the whole code will break and I will not notice it. And we try to band-aid it with ESLint. We are like, okay, I will just export these constants and import them, and ESLint will tell me if I try to import an invalid value. So something like this. And it gives us some confidence, but with a type system, you actually don't need that. Let me explain why. Because in our actions, we are defining, first of all, we can import our domain types. So we are handling user type, for instance, somewhere which comes from backend. We can reuse these types almost everywhere. This is also a very nice feature of static type systems. We have our, I will come back to that later on. We have a type fetched user action. And this is like just a typical REDUX action with a type property fetch user. And this is a string literal. So we can define a specific string to be applied on the type. And if it's a type fetch user, we have a user ID which is a string. This is a fact. If it runs through the system, this is a fact. I don't have to type check, I don't have to like check for null values or whatever. This is it. Then we have a fetch user success action. I'm just like making up some actions to give you some idea how the switch looks like. Fetch user success with a resolved user object. Okay. But these are just the elements. Now we can make more complex types. We can compose them together. So we can make a union type, which is an abstract called user action. This can be a set of actions which can apply. Either it's a fetch user action or it's a fetch user success action. And now if we use an action creator, for instance, we have our fetch user action creator. I just assume this is a side effect free action creator. We say fetch user gets a user ID. And if you remember, this fetch user action has a user ID as a string, so we enforce it here. And we return a fetch user action. If we try to return an object which is malformed, Flow will tell us. So we don't need a constant here. We don't have to like duplicate all this stuff. I'm just like repeating two words in a string and in a variable name. This is kind of weird. And let's go to the reducer maybe. So now we have this nice way of defining the state. I don't know how much you developed with Redux and what use cases you had. I came to a project where I had no idea how the state looked like. They were just like putting in, maybe they had some initial state kind of thing, and they put in some like an entity property, and the entity property was just an array of objects. But I had no idea what kind of objects they were. And here I can really define how the state can look in various scenarios. So maybe the state has a user object, which is maybe a user, so either an object or null. Or I can have transient states, like loading state or whatever. I can make it optional, so it doesn't have to be, it can also be undefined in the state. Or we have a user ID which can maybe be a string. And we can also use this state later for our containers if we try to connect values with map state to props or something. So we import our user action. This is a specific syntax of Flow. You can separately import types. This is going to be stripped away from Babel. So this is not landing in your runtime code. And we have an initial state, and I just want to make sure that I'm not making a typo here, so I just define it to be a state. It's very similar to how typecasting in C or in Java works, or variable declaration. And we have our reducer, and this looks a little bit weird. I just moved the parameters in each line. A reducer gets a state, which is type state, which is initial state. So you can see this state and this state are the same. We get an action, which is a user action, and returns a state again. And then we have the switch. And now comes the really, really powerful, part of Flowtype, which is type refinement. So, as I told you, Flow does code analysis as your code flows through like your conditional things, like ifs and switch and stuff like this. And I already showed you that type can either be fetch user as a string literal or fetch user success as a string literal. And Flow can distinct between. This is called disjoint union type. So if action.type is, and we know it's a user action, if it's fetch user, it knows, okay, it should have a user ID property there, and it's guaranteed to be a string. And if I get a fetch user success, I get a user object, which is guaranteed to be a user object. If I try to use user in here, it will tell us, I don't know, user. You're having here a fetch user action. Oh, there's also a default case. I just don't put it there. I was lazy. But one cool thing, I saw already like some maintainers of Flow experimenting with exhaustive pattern matching. That means I could analyze if I'm missing a case. So if I add a new action called fetch user fail, and I don't define it here in the switch, Flow could tell me, hey, you're missing a case. And then we would theoretically not need a default case. But yeah, just use the default case for now. Forget what I say. So the last part, our UI, which should be stateless pure functions. So first of all, we import type user. This was very important, as I told you before. We can reuse our domain types, and now we define our prop types. And we define our prop types as flow types. So we can say user is a user, and another thing, we can define functions, like our onClick function. And if you use React prop types, it's very hard to express like functions. You just say React prop types function. I'm not sure if you can even define like the properties of this function, if they are having a parameter or if they are having a return type. I don't know if React prop types is capable of analyzing this, but Flow can. And in our functions, we just don't use the prop types, we just use props, which is like defined by like React, how this whole thing works. So we define it to be props. And there is a bubble plugin. Usually this code will be stripped, right? So it will just tell you during your development time if you pass in the wrong JSX prop or something. You can even make this work for runtime if you're using a bubble plugin, which is called, I don't even know how it's called, but it transpiles these props into React prop types. So you don't have to write it at all, you can just create your typical flow types, you use your domain types, which you need anyways for your pure functions, and then transpile them later or compile them later on into actual code. So you get both. You have runtime checking and development checking. So let's get to the tedious part, which is third-party modules. And third-party modules are kind of hard. So what if I try to do this import Lodash from Lodash? It's very complicated because I don't define this. I'm not responsible for this code. Like the maintainer probably doesn't even use a type system yet. And we still need to teach Flowtype about the existence of Lodash. And we should tell it what types it exports, what functions it exports. And this is why I told you before, Flowtyped exists. Flowtyped is a project on GitHub. It's on flowtype/flowtyped. You will find the link later on. And what it does is, not only does it provide you with the definitions for third-party modules, but it also supports a command line util. So you can just do npm install globally Flowtyped. And what you get is, if you have a project with a flow config in there, you can just type Flowtyped install, and it will read your package.json dependencies and your flow version, and then make a lookup to our repository and check if there is an available library definition for this specific version, for this specific flow version. And we'll put it into a local folder called flowtype/npm. It's namespace, so you can still manage your own library definitions if you want to. And you can just take these Flowtype definitions and check it in your Git repository. You just commit it. Because if there are changes later on, you can just use Flowtype update or upgrade, like npm update, and it will pull up the dependencies. It will recognize, okay, this is out of date because it just uses a header for commit hashes, and it can automatically help you updating your library definitions, as I told you before. This can be very useful to see major breaking versions. Okay, so the whole gist of this talk is I want to make our lives easier, and I want you to help us to make our lives easier. First of all, we should at least try, or at least dabble around with the type system. Just get a feeling for it. The nice thing about Flow is it's just JavaScript. If you don't like it, there is a bubble transformation or even a GS code mod, if you know that, to strip away the Flow code and just print out the JavaScript with the original formatting. So if you're deciding, okay, this is probably not what I like, you can just opt out. It's not a different language. This is very important, but at least try it. We can enforce self-documenting Saner code with code completion without any JSDOC which get out of sync. We can make library definitions possible, because if I think about complicated libraries, as I said, a lot of people do meta-programming and they like it and it's super dynamic and super dry, but in most cases it doesn't make any sense to mix up too many responsibilities. So if you split your code in a more modular way, which a type system kind of enforces you, you have to think a little bit differently when you write your code, because you want to match all those types. So if you do that, you make our lives, because I'm working on Flowtype a lot, I'm also merging stuff and writing my library definitions myself. If the library is capable and if it has types already, I can just look it up, I can just see it, it's much easier to get into the code. Cool, so that was the whole gist of this talk, and just a short announcement, if you're interested, because Brno is quite close to Vienna, right? And we have our meetup group, React Vienna, and I want to promote this whole idea. As I told you, my mission is to bring static type systems to JavaScript, and I want to offer a workshop for that. So if you are interested in learning Flowtype, it can be beginner level and intermediate. In the end of March or in the beginning of April, I will send out there will be the workshop, but I will send out, if you register on my email address, just send me an email if you want to attend. This is mandatory. I will send you the information later on, the curriculum and the exact date. Okay, and this is also for free, by the way. This is sponsored by React Vienna. Cool, so that's it, and I'm up for questions. Thank you very much.
You said that you worked on a Flowtype project. Could you talk a bit about integration of Flowtype with Immutable.js? Because Immutable.js has its own internal structures, you have own records, and most importantly, you have map. How does Flow play around with it?
So, Immutable.js is kind of hard to deal with, I know, since it's using a lot of generics, and it's also originally written with TypeScript in mind. I don't know what kind of problems you exactly have, so maybe let's talk later about it. Personally, I try to avoid using Immutable.js as long as possible. unless I really, really need it. Because we lose a lot of advantages like this prop type typing is kind of hard with Immutable.js, and it just makes the code base much more complex than it really should be. But I cannot answer the question right away.
In that UI component example, the prop types example, how do you apply that prop to functional component?
If you're using a functional component, it's a function. So you just have a function with a props parameter, and you just make a typical function annotation, props, colon, props, and returns a React element.
You was talking about Flowtype install. So it's looking in some database of already done stuff, or it's creating its own abstract syntax tree and creating it from scratch.
Flowtype does it very funny. So what it does is it clones the Flowtype repository with all its definitions in your home directory, and the definitions are, if you look into the repository, there's a definitions folder, and it just has a certain naming convention. So you're ordering like different folders with your library name and your major version or maybe minor version, and then you put your Flowtype definitions in there, your library definitions. And there's also a test file for that. And this is structured in a way that Flowtype will also, if you work on that and if you want to create a pull request, will automatically run the tests, like the type tests, and tell you if you do something wrong. And to answer your question, if you say Flowtype install, it will clone the repository, and then with this naming convention, it will find all the packages and install it into your Flowtype npm local folder in your project. And yeah, that's basically it. If there is a non-matching version of it, so if we cannot find any library definition, it will create a default file for you, which exports any. So it's not typed at all, but at least Flow will not break because it can find dependency. So what you can later do is, if you have dependencies which are not typed, you can gradually add the definitions very easily, because usually if you use Lodash, for instance, you just need like 3 or 4 functions, right? So you just define map and reduce and whatever. And if you think it's like usable for different like other developers, you can just share it in a pull request. And we want to add support that you can do that from your project right away with Flowtype CLI. So I hope this answers your question.
So it's sharing database between developers.
Yeah, it's just a Git repository of Flowtype itself.
So I've been using Flowtype for a couple of months now, and your presentation, a couple of times in your presentation, you used the type definitions and declarations. And it got me wondering, I've been using interfaces instead in all of these places. What's the difference between an interface and a type?
So an interface, so the difference between an object and an interface is the way covariance works and which values need to be there and which values you can easily mix up interfaces, and you can also implement interfaces in classes if you want to do so. There's also the implements keyword now. I personally don't use interfaces too much, so I cannot really tell the major difference. Like, for me, they work kind of the same like object definitions.
In that type definition, the optional and the maybe type, can these two be combined? Because in JavaScript you can equal to null, and it will match null and undefined both.
Yes, Flowtype is agnostic of that. So what I usually do is for ESLint, usually you have the ESLint triple equal rule, right?
You can realize it's double null.
Yeah, you can have the smart thing that you just have, equal null will check for null or undefined. So usually, if I try to check for null, I just use 2 equals. And then you are covered.
You
in
can
all these.
define this kind of type in Flowtype, you know, the main type and the optional, because the question mark is in front or
Yeah.
in the back.
Optional means it can be null, it can be undefined. And
Okay.
yeah.
And so, do you think that prop types is like really totally useless when you're using flow type? Because if someone is not using flow type and you don't have the prop types, like in VS Code, you miss all these auto completions and all these things. So I usually like, I may be crazy, but I keep like prop types, then flow type props, and also the basic like JSDOC, right?
Yeah, I highly recommend dropping the React prop types. It's also evangelized in like all the Facebook teams, kind of. If you're afraid of people not using Flow, you can either just drop in the bubble plugin, as I told you, and they have no way of not doing it because they have to transpile the code.
Okay.
You're just much more flexible with flow types.
So you just use the flow type, and maybe as one little question: is there some like tool which like can export like some documentation in HTML from flow type? Because I really didn't find like something like that.
Not that I'm aware of, sadly. I know that Visual Studio Code has something like this for TypeScript. Yeah, I've never needed it yet, so.
Can you compare TypeScript and Flowtype, and what are advantages of Flowtype from your point of view?
Okay, this is a good question because a lot of people ask me that. First of all, disclaimer, I never use TypeScript. I'm just observing the project from the distance because I'm always interested what like the other team is doing. Flowtype and the TypeScript team are usually like they're communicating with each other. They're aware that they are different. The algorithms are a little bit different. There are some small difference in how the tools analyze the code. TypeScript has some downsides. They even documented it on their website. How the subtyping works, the covariance and the variance. So what TypeScript does is they try to make it a little bit more convenient for the developer and sacrifice a little bit of correctness, like how it works. Sometimes there can be still errors, but you can mitigate that by just being aware that these limitations exist. TypeScript in general has better eye support or like community support because Microsoft has been investing heavily into this whole thing, and also Visual Studio Code is written in TypeScript. But the major selling point for me in Flowtype is I'm using a lot of functional paradigms. I'm a huge fan of functional concepts, and for me so far I'm doing a lot of function composition and all this crazy stuff. I'm using a lot of React, and Flowtype does support both of those really, really well. And I cannot confirm this, but I also heard a lot about people complaining that the type inference of TypeScript is sometimes really funky, and that you have to annotate a lot of variables so it recognizes the types correctly. So I would recommend checking them out both. TypeScript itself is a different language, which compiles JavaScript. And before I use a different language, I would just go with a functional language like Elm or ReasonML even. I'm British, or ClojureScript is also really nice. Before I would do that. But this is just a personal preference.
May I ask you what IDE you use for TypeScript for?
I'm using Vim.
Vim, okay.
Yeah.
I just checked there's some plugin for Flowtype in WebStorm. So, do you have any experience with this? Or?
So, yes. I haven't been using WebStorm myself, but I've been working with some teams where I introduced Flowtype, and there was this one guy who was using WebStorm, and in the beginning it was a little bit funky because he has been using an experimental version of it. And he enabled the Flow plugin, and as soon as he enabled it, it was super slow. The editor got terribly slow. And probably this is also what people experience with ESLint. The thing is, you should disable the option to type check on every keystroke. So there's an option, if you type one keystroke, it makes a request and tries to do stuff. Just disable that, and after that it should work quite stably. So,
Okay.
but in general, there is an atom plugin. There are several atom plugins. You can use Nuclide, which is made by Facebook, so they try to make it nice. There is a Sublime plugin and Emacs as well.
Even for VS Code, I'm using VS Code with Flowtype plugin. It's really good.
I'm pretty sure there will be one, but
No, I know it. I use VS Code and use Flowtype plugin.
There we go.
So,
Cool.
because VS Code has really good plugin for React Native, and I was using Nuclide for a while, but VS Code is, I think, better.
Cool. Let's go to here. Okay.
You know, one question?
Yeah.
I'm a big fan of Redux observables. Are there any support for observables?
Yes, we have RxJS in Flowtype, like in the Flowtype repository.
Okay.
I never used observables though, so you need to check it out. Oh yeah, by the way, if you happen to be a library maintainer and you want to try this out, and you want to write library definitions, and you want to push a PR on our repository, just let me know, because I can merge it. And if there are still some problems or something, if you need help, you can just come to me and I will help you out. Cool. So I will be around here anyway, so if you still have any questions, just come by, say hello. Thank you for your attention and have a good evening.